So our goal is to solve for I of t. To do that, we need to know what the derivative of r is with respect to t. So this is our r of t function up here. We need this derivative, and so that's where the link to derivative calculator will come in handy. So if we go over there, let's see, so if c, I think it was 22,243 for this person, and then it was, we need to multiply that by e, and then I'm going to use parentheses, 0.05x, or you could say it in terms of t, and I think this online calculator knows to change the variable from x to t, so that should be okay. Now look, if you hit divide, that's going to be okay, but if you want to have the whole thing as a fraction, you can wrap it in an extra parentheses, and then press the divide key. And so that gets the fraction that we're looking for. And so as the formula says, then it's c plus e. So here, you got to put your denominator in parentheses too. That way it takes the whole denominator. It's 22,243 plus e to the power of 0.05 t. And that looks like the formula we have here, right? C times e to the RT power plus, divided by c plus e to the RT power. Okay, we got everything typed in correctly. Now if we let the derivative calculator do its magic, simplest form is this one right down here. Okay, and that, I think that's the form that's in the sample sample PowerPoint. Where is that? It's linked here somewhere. The example PowerPoint. That's, you can check it to make sure it matches, but that's similar. It's, you're gonna have different values, different c's and different r's depending on your situation. So that's your derivative. The last thing you need to do in order to get I of t by itself, where is it? Is multiply both sides by k, by whatever your k was. Okay? And so if you do that, take this is your derivative, multiply that by k, then you have your function I of t. So in part D, we're supposed to find the day where the maximum number of infections have occurred. You know, that's taking a derivative and setting it equal to 0. So we want a derivative of the infected equation. Here, actually, let me double check something. I was typing in just to see. That should be 0. Okay, yeah, that doesn't make sense. There's probably a lot on the list. Okay, that was just something I was doing to check because it's tedious. It's definitely tough to type all this in. But to find out the maximum number of infected people, we need the derivative of the infected equation. So we'll go over to our derivative calculator, and if you solve that infected equation based on what we had before, k equals 10. So to solve this equation, you just have to take the derivative and multiply it by 10. That will get you I of t. And you need to find the derivative of I of t, so let's do that. Sometimes it's helpful to start with a parentheses for the numerator and a parentheses for the denominator and put that division in there. Okay, that's times e, times e, open parentheses, to the 0.05x power. That's the same thing as 1 at x divided by 20, right? So that's the numerator of our infected equation. The denominator is 20 times e to the 0.05x plus 22243, and square that. Just checking to see if I got everything typed in. That looks good. I think that's what I just saw down here. Oh, I lost it already. That's the infected equation. We take the derivative. Here, we're going to want to type that in Desmos, the derivative we see. So let's just have both these windows going. Oops. Okay, this is what they gave us for a derivative. So when we find critical points, if we're looking for maximum or minima, we're taking a derivative, we're setting it equal to 0. So this is our derivative. There's e to the 0.1x. X is t, right? We're just using x because it's more convenient typing it in. I'll move it a little more so you can see what I'm typing. Okay, that's the numerator. And then in the denominator, we had 40 e to the 0.05x plus 22243. And then this is all to the third power. checking to see if I get it typed in right. That's good. That's good. Okay, that all looks good. So if you look in Desmos, we're taking the derivative, setting it equal to 0. What does this one represent? Okay, well, if you take the derivative, set it equal to 0. Oh, sorry, we don't want to look at those at all. That would be, I forgot we're looking at the derivative of infection. So these would be inflection points, right? Because that's where the second derivative would equal 0. That's where the first derivative is leveled off. So we're looking to set this equal to 0. That's why we typed it in, right? So we set it equal to 0. We got roughly 200. On day 200, we expect to reach a local maximum, and you could verify that too. If you type in the original infected equation, I of t was, for this person, 4947510,490 e to the 0.05 times x power. That's all being divided by 20 times e, times parentheses e to the 0.05x plus 222,443. That's being squared. Yeah, so if you graph the original infected equation, look at our first, when we set the first derivative equal to 0, we got 200 for a maximum. And if you graph it, it's confirmed, right? At roughly 200, we reach a maximum for the number of infected people, about 2,780 people. So that's what we'd say. For what part are we on? That's our answer for part D here. Okay. Okay, I think that's everything. I've got another video for helping out with part E too, because that part's pretty tricky. But email me, message me if you need anything else.